Hello everyone, welcome back. So let's take a look at this idea, and this is something I haven't covered before, and I think it's going to be a great way for you guys to add realistic debris. In fact, this is using bullet. I'm not using particles and instancing, and I prefer this method a lot more. I do have this twist here that I couldn't figure out why it's happening. You see that particle doing this, the RBD doing that? I don't know why that's happening, but it's working. So let's take a look. I have the packed geometry, and what I did is I unpacked it and computed the velocity vector. It's very, very important to compute velocity, and so I have velocity onto this, and whenever there's a big drop, you can see the velocity is going it's changing quite a bit, and you can see the direction of the vector is quite good. If we wanted to emit from that, it's going to work really well to emit debris going upward. And I'm going to remove everything except the inside, because I want to isolate the inside to emit from. And I'm creating a rest attribute on them, so that I by freezing the first frame and then using a rest node. And then I'm going to scatter a bunch of points, and I'm going to isolate only the points that are at the edge. And I'm not deleting them based on their current position, but instead using the rest position. And let me increase the number of points so it's very visible. So those are the points. And using the velocity, we're going to isolate the parts that are changing only. So let me reduce this so it's faster. So if we fit range the velocity, we're going to find out which part gets activated, and then I'm going to isolate those only. So let me delete this because we don't need a lot of points for this to work. And I'm going to cache this so it's faster. And you can see we have points only where the impact is happening or the edge are separating. And if we hit play, those are our emission points. And I'm moving them down a bit just so they are not exactly on top of the surface. And we can use this with a particle sim, which I have here. So this is very basic particle sim that uses the velocity, and we're emitting points from that. So that's one way. And then the other way is to delete all of this. The other way is to use a technique where we copy geometry onto points. So that's fine. So this is my geometry, and the idea is we're going to create we're going to copy a random piece onto each of these points. And then we're going to give it a angular velocity and a velocity vector, and then use this to emit dynamic RBD into the scene. Let me delete all of this. So what I have here is I have a bullet solver. I have an RBD packed object. It's set to active, and notice it's empty. It doesn't have anything. And then using a pop solver that is set to use first contacts, which is the first input, and I'm feeding these points. And by doing this, we're going to automatically emit dynamic RBD objects. So this is something, maybe it's something that happens with bullet. So you have an RBD packed object, you have a pop source, and you set the emission the life expectancy to really high number. We're going to get RBD object emitted from those. So this is our sim. And then I have a collision geometry that I'm going to show. So this is an SDF that I made from the ground, and I just converted the geometry into an SDF, and I also have, and I'm setting the collision to concave. So if I show guide, you can see here it's set to concave. I made a huge gap between the pieces, but I think it's too much. I didn't want them to intersect too much, but I think this is too much because they are falling through the cracks now, and I didn't want that. And let me show how I did this. So we have the geometry here, and I looped over each piece, and I transformed it down based on its centroid using the $CX and I think this is too much, but I'm scaling them down, and then polydoctor to clean them up, and then I'm looping over all the geo. So this is how it looks like, and then using a VDB from Polygon to create a VDB, and then VDB reshape to pick the geometry in. And actually I'm gonna turn this off. I don't think it's a good idea. And then I cache this to disk. Let's see if I can fix it back. Not erode, but dilate 2. Yep, so let's try and fill those gaps. So this is our SDF, and then I'm using a VDB convert to generate geometry from that. It's messed up geometry, but it works quite well. And I'm using really high adaptivity. And then I'm feeding that into the RBD system. So this is the geometry, and I'm setting the mode to concave so that it creates proper collision for this. And that's, let's see, I'm gonna hide this, and let's hit play. And for the velocity, I'm using the current velocity from the geometry, from the points, and I'm inverting it so it points outward because the geometry is going downward, and I want the invert of that. And I'm introducing another velocity inside here. So I'm inverting the velocity. I'm using a quarter of its value. I'm adding some velocity along the y-axis, so push them more, and then just some variation here. And let's take a look. Yeah, much better now. They're not falling through the cracks as much as before. And I'll talk about the emission, how we're copying the debris in the next video. Let's take a look. Much better. And then the second impact happens, and that as well will also emit RBD, more RBD objects. Okay, let's take a look at the debris emitter setup in the next video. Thank you guys for watching, and see you in a bit.